We all think of AI as this global, universal thing, right? But what happens when it doesn't actually speak your language? For most of the world, that's a huge problem. Today, we're diving into the incredible story of how one community taught AI to speak Romanian, and in the process, created a blueprint that could change everything for thousands of other languages.
So let me ask you, does AI really speak your language? Now, if you're an English speaker, the answer probably feels like a clear yes. But for pretty much the rest of the world, AI's fluency is, let's just say it's a work in progress. It's a technology with a massive, built-in bias toward English. For the roughly 24 million people who speak Romanian, the answer was a definite not really. Even the world's most advanced AI models were tripping over their language. But here's the cool part. Instead of waiting for big tech to maybe someday get around to fixing it, they decided to take matters into their own hands.
Okay, so let's get into the why. What's at the heart of this? You could call it the Anglophone AI problem. The reason most of these huge models basically think in English is actually pretty simple. They're trained on the internet. And the internet, as you know, is overwhelmingly English. This gives one language a gigantic head start and leaves thousands of others in the dust.
And when you look at the numbers, it's just wild. Take Common Crawl, one of the biggest data sets that AIs learn from. Romanian makes up this tiny, tiny sliver, just 0.6% of the data. 0.6. I mean, when your language is less than 1% of what an AI studies, you just can't expect it to be any good at it.
And that lack of data creates this domino effect. It's not just about the text itself, it's about the tools you need to work with that text. According to the GRIL benchmark paper, the number of natural language processing tools for Romanian is only about 15% of what's out there for English. It's a vicious cycle, right? Less data means fewer tools, and fewer tools make it even harder to build anything useful with the data you do have.
So, faced with this, the Romanian AI community decided to put these global models to a very local test. They asked a really simple question. Could the world's most powerful AIs pass a Romanian high school grammar exam? And we're not talking about some easy pop quiz here. These are questions from the high-stakes national exams that students actually have to take.
The results were pretty revealing. Even these super sophisticated trillion-parameter models totally stumbled when they were faced with the real nuances of Romanian grammar. This wasn't about just translating words. It was about deep contextual understanding, and frankly, the models just weren't there yet.
The GMILE benchmark laid it all out in black and white. A top-tier commercial model like Gemini 2.5 Pro, it scored a respectable 83%. Not bad, a solid B. But the open-weight models, the ones most developers can actually use and build on, they told a very different story. A lot of them fell below 65%, and some were as low as 38%. That's a flat-out failing grade, and it proves there's a huge performance gap. Seeing those numbers, the community had this big realization. Simply fine-tuning the existing, English-centric models wasn't going to cut it. That was like trying to put a new coat of paint on a broken-down car. They had to go deeper. They had to build their own tools, their own data, their own models from the ground up. And where do you even start with a project that big? Well, you start at the very, very beginning with something called a tokenizer. Now, that might sound super technical, but it's an absolutely crucial first step. Think of it as the AI's alphabet and grammar book all rolled into one. It breaks text into tiny pieces the model can process. If that first step is inefficient, everything else that comes after is going to be handicapped.
And this chart shows you exactly why they needed to build their own. They measured what's called the fertility rate, which is just a fancy way of saying how many tokens does it take to represent one word. Their custom tokenizer for a model called LMIC is super efficient at just 1.38 tokens per word. Now compare that to the general-purpose tokenizers from Llama 3 or Mistral. They're almost twice as wasteful. Better efficiency means a faster, smarter, and cheaper model in the long run.
So that custom tokenizer became the secret sauce in the LMIC recipe. The team had a really clear plan. First, curate a massive, high-quality data set of 300 billion Romanian tokens. Second, build that super efficient tokenizer. Third, use all that to train a brand new 3 billion parameter model completely from scratch. And finally, fine-tune that model to do specific jobs, like translation.
And you know, the most amazing part of this story isn't just the technology. It's the people. This wasn't the work of some giant corporation with a billion-dollar budget. No, this was a true grassroots movement. Groups like OpenLLM, university researchers, and just passionate, independent developers all banded together to tackle this massive challenge.
And they moved incredibly fast. I mean, look at this timeline. In less than a year, the OpenLM Rho community went from releasing its first few fine-tuned models to dropping benchmark data and then launching the full-blown LL-MIC foundation model. That is a stunning pace, and it's all driven by that collaborative open-source spirit.
So, the million-dollar question, did it all work? Oh yeah, the proof is right here in the results. For English to Romanian translation, the custom-built LL-MIC, with just 3 billion parameters, scored over 41. That absolutely demolishes much larger models like Llama and Mistral, which are more than twice its size but are stuck down in the high 20s. It's a huge, huge win for specialization.
I just love this quote from a Reddit user talking about one of the community's models. It perfectly captures the spirit of this whole thing. This isn't just about code and data, it's about cultural ownership. It's about building technology that gets the local nuances, built by people who actually live and breathe the language.
So what does all this mean for the future? Well, the Romanian story isn't just some isolated success. It's a powerful case study. It's a blueprint for how other underrepresented languages can start to claim their own space in the world of AI.
So what are the big lessons here? First, data is destiny. You absolutely need high-quality language-specific text. Second, custom tools like tokenizers aren't just nice to have, they are essential. Third, community is the engine. Collaborative, open-source efforts can absolutely compete with big tech. And finally, remember that smaller can be better. A specialized model can totally run circles around a giant, general-purpose one on specific tasks.
And that brings us back to that big question from the beginning. Is the future of AI going to be truly global, or is it just going to be an extension of an English-speaking world? As this whole Romanian AI revolution shows us, the answer to that question is being written right now. Not in Silicon Valley, but by passionate communities just like this one all over the globe.